Good morning, but good afternoon, everybody. Welcome to my HAR. It will be very funny. No, it won't. But you have to judge whether it's funny or not. No. So today I'm going to talk about debugging and tracing HTTP client requests. And so, yeah. Hopefully everybody's... Has anybody here not used the ABL HTTP client? Maybe I should ask nicely. Hey, Tom, I know you wrote your own database administrators. So everybody's got some experience with it. That's awesome. All right, so my name is Peter Judge. This is the third time today I'm seeing myself on the slide here. I work at Consultingwerk. I was previously, or most recently, at Progress, where I did a lot of work on the HTTP client, design and implementation of it, or some of it. And that's the kind of stuff I like to do, kind of integration technologies, that sort of stuff. I work for Consultingwerk. We're a consulting organization. We also have a smart component library framework that we can use for modernization. I'm going to skip over this somewhat quickly. Again, what we do, OpenEdge centric, but most of the Progress products we have some expertise in. Or expertise in most of them, I should say, not some expertise. And similarly, other Progress environment products. All right, so HTTP, it's fun, it's easy, everybody loves it, right? Easy to do, it's awesome, it allows you to talk to the whole world. It has a number of components. The HTTP client in ABL was written or released in 11.5, 11.5.1 maybe. And it was written as an internal engine for the mobile client. So for push notifications, they all work on HTTP stuff, and there was nothing like that in the product. So in an advantage for ABL, it was written in ABL rather than embedded in the C code. So here we have it. These are basically the constructs that we work with. We have a client, an HTTP client that we can use to make requests on. So one client, multiple requests, we get a response back. Response has got, your standard stuff, status code, it's got a body, it's got a bunch of headers, it may have cookies, it might have a variety of things, right? But that's kind of what we work with. Those are the important things. Client builder is the public API, if you will. There's a thing inside called the client library, which is the code that does the work. So today that uses ABL sockets to do it, to read and write, but one could potentially swap that out for a curl-based thing or a .NET client-based thing, and the programming interface stays the same, which is cool, I think. It's a bunch of builder objects, so sometimes people will talk about it as the request builder, as kind of the thing. Yeah, as I say, we build a client, HC, we build a request, right? Going to that post, this is a useful site for testing stuff, and we execute the request. And then we get the data back and do something with it. Now, the execute does a couple of things. Firstly, it sends the requests, but it also knows how to deal with redirects. So if you get a 301 or a 302 or a 303, as I discovered, there's a 303 status. Anybody heard of that before? See other. Jira uses it, incidentally. So there's redirects that it can do, and it can do retries, and if you get a 403, a 401, an authentication failed, it'll do the redirect and try and do the thing. So, one request may turn out to be multiple to potentially different servers, different URLs on the same server. So that's easy. What could possibly go wrong with that? Well, first thing is SSL always goes wrong, the first 6 or 7 times you try it, but often it's a bad request you build. If you build something if you're making requests to, I'm just going to pick on Jira or Confluence or other third-party things, they may document it poorly. So you don't actually know what you're supposed to put in the thing. Oh yeah, you're supposed to put that header with this value, or the user agent's supposed to be this or that or the other thing. Something is wrong in the request, you get a 400 back. Bad request. What else? Content types are wrong, right? You didn't ask for JSON, you thought you were going to get JSON back. The accept header wasn't set, and now you're getting XML, and your code says, object model parser, pass, and it's like, ugh. It's that sort of stuff. Redirects are annoying, can be annoying, and as I said, the HTTP client does them for you. So you don't know whether or not something's been redirected or not. So you may get a failure. You may get, as often happens with authentication, you may get a failure. You're like, what went wrong? Why am I going to this site over here? So you don't know why you went where you went, that sort of stuff. There may be client issues, right? So the OpenEdge client may not know how to convert certain data types into real objects, right? So the data that comes back off the socket or back from the server is usually a bunch of bytes, and the HTTP client tries to convert that into something useful, JSON object or something else, string or an XML document, if it's XML, something that you can use rather than you having to do it yourself. But there are how many bajillion different content types in the world, right? Like if you go to the IETF's site on content types, there are thousands and thousands and thousands of them. There may or may not be bugs in the product, right? Who knows? You know, I wrote some of this code, so it's definitely buggy, but there may be other bugs in there as well. And then server issues, right? The server went splat because something happened on the server. Who knows? You may also care about performance, right? Why is this taking so long to return the data? Is it the server taking a long time? Is it the client taking a long time? You don't know. So until recently, until 12.5, I'm just going to call this classic. The way you debug things in the HTTP client was you basically turned on the logging level. You set the logging level log manager to a certain level, 5, pick a number. Well, 5 was the one you really want. You can set up logging using the ABL logging with that config file. And then when you run your requests, firstly in the log file you get, this is what we sent, this is how many bytes we got, this is da-da-da-da-da-da-da-da, and it writes some timings in there. It also writes a set of files. So firstly, what's called request raw.txt in your session temp directory, and that is, anybody seen this file before? Anybody? Everybody else has excellent HTTP clients. That's got the request. Like as it gets sent, right, the whole protocol, you know, so get space URL space HTTP 1/1 or whichever around it is, I never remember. That whole line, the headers, the correct formatting, hopefully, all of that sort of stuff is written into that file. On the return side, it gets a file called response data received, which is the blob of bytes that comes off the server, right? So HTTP 1/1 space 200 space OK, or 418/I'm a teapot, or whatever that might be, the headers, the cookies, all of that sort of stuff, the bytes that come back, just dumped onto disk. So you can see what's gone wrong, if anything's gone wrong. It's handy, you know, if you've got parsing errors, it's handy from a progress point of view of debugging stuff that went wrong. So often if you phone tech support with an issue, progress tech support with an issue on the HTTP client, they will ask you for these files to help debug the issue, to help engineering debug the issue. You could also do something like set up a proxy, right? So use Fiddler or whatever other proxy you want, and all the requests go through there, and most proxies have got some kind of a logging where you can see, you can dump the requests and the responses out and all that sort of stuff. That's not bad, it just, you know, you can keep doing it that way. As I say, timings are usually in the classic model, in the log file, and you can kind of infer how long it took to connect to the server, get the data, read the data, write the data, all that sort of stuff. So we shall have a quick look at that. I hope I can just swap screens and you can see my... No, of course not. That would be too easy. So now we're going to have to do this dance 6 or 7 times, I'm sorry. All right, so I have a little program here, just a .p. It's got some logging here. We build a client. I'm just setting num retries here. I've got some retries to do, so I don't want to, the default is 10 retries, which is just a lot of stuff. So we're going to build 3 requests, or we're going to send 3 requests, but we're going to send a request to this hello guy. We've got some credentials in there. I've got a PAS instance over here running that's going to consume that. And we're just going to look at the response code, right? So I'm going to compile that, and let's run it and see what we get. So this is my temp directory over here. I'm sorry if you can't see it, it's pretty small. It's got nothing in it right now. And we're going to run that, and it's going to chug away. Gives us a 200. I'm sorry. And so what we can look at there, if something went wrong, is we can take a look at the request raw, which looks like this. This is what what I will do is white space characters. There we go. So you may not be able to see them, they're light gray, but there's one of the things with HTTP is the header block and the distinction between the header and the body has to be carried return line feed, not line feed. It's one of the things. So we can see what we sent, right? We sent a request ID, header, a user agent, authorization, and that's, that's cool because somebody can just read that and say, let me get there, let me go there, base 64 decode, and we can go into a 64 decoder and we can see your username and password, which you probably don't want. Well, you probably don't want in your logging, so not great. So that's the one thing. So if we just change our request to a redirect. Excuse me. Not that. I don't want Z. I don't want that. I want that. Alt. We'll just do that redirect. And so this http-bin.org is it's basically just an echo website. It's got some functionality and it's just good for testing clients. We've been doing it for testing clients for ages. And this is going to give us a redirect to 302 and a redirect to some other site. In fact, back to where we just came from. So when we run this, it gives us a 401. And so we can look at the request that we've got here, and it's get/web, right? So that's not what we were looking for. We were actually making a request to bin.org, right? The server there is localhost and not. That's the redirect, and we're getting the 401 because we didn't put any credentials on that because we can't. So we've lost a little bit of information in doing this now, right? We've got one request, but it's always the last one. This is a very simple example, but if you've got a complex thing, so for instance, if you want to query Jira, to find a bunch of data needs 5, 6, 8, 10 different calls to get all of this stuff, right? To get a whole graph of things. And if one of them goes wrong in the middle, you're never going to see the data you need. So that was one fundamental problem with this. All right. So back we come here. I'm going to see if I can do this without the slideshow, without the presenter view, because I think then I can switch over. Can I switch over? Yes, that's what I want to do. All right. So back in the 12.5 timeframe progress, the kind of goals were, a couple of other things, but really for this piece we're talking about here, what did we want to do? We wanted to say, well, we need to be able to gather all of the data for that one logical request, right? So we did that redirect, which was a request to http-bin.org. It got a redirect, went back to localhost and back. So 2 physical requests, but a logical request, right? And you may get more, right? It may just ping along and redirect and do all of that stuff. So that was one thing. Other thing was gather it in a standard data format, some form of standardized data format. And there aren't really formal standards for this, but a standardized, commonly used format. The other thing was, as things stood in the classic world, you could only turn this stuff on and off largely in code, right? So there's ways of doing it, but largely people would put the log manager in to the code, run the request, and then have to take that out again, which is not great. You kind of want to deploy this and have a remote switch, if you will, to turn it on and off. So that was one goal. The other goal was making sure we could configure what data you would gather. Like, do you want everything? Do you just want some content types? Do you just want some URLs? Do you not want some URLs? So let's say you send your username and passwords in the body of a request. Do you want to trace that? Do you want to record that? So that's a decision to make. And the last thing is, where is that data written? To disk, to a database, to a socket somewhere, to another HTTP request, which gets a little hairy, but you could potentially do something like that. And in terms of controlling who manages when this data is written, make it an admin, right? So you don't want to require the programmer to redeploy a new .p every single time, right? Can it be something that is done from an administrator who writes some kind of file on disk or flips some switch, something like that? And again, somewhat with some more security, right? Do we really want people being able to pick files up off disk like that request rule and see usernames and passwords, right? I know people are moving away from basic authentication, but potentially they could have a bearer token in there which they could use for a replay attack or something like that. You don't really want to leave secure information lying on random disks in your temp file system. So that was the goals. So there's kind of two parts to it. Kind of like if you know the profiler at all, if you've written code in your application to turn the profiler on and off, you know there's two parts. One is profiler enabled, and then there's profiler profiling. So one says turn the feature on, and the other one says go and do the profiling now, and then turn it off. We followed the same model here. So the first thing to do was to say allow tracing true or false, right? So at the top, it's for a whole client. So remember I said the HTTP client is reusable, so you could have a client that's tracing on, and then all the requests that go through there will have tracing turned on, will potentially have tracing turned on. So this is kind of the feature turn on. You can also turn it on and off for a single request. So if your developers know that they are sending credentials to somewhere, do we ever want to log that stuff, trace that stuff? So you can have a kind of a hard boundary of on and off there. And that's the first step. Second step is, by default, there is a JSON file on disk called hctracing.config. And in there, there's a switch that says, do the tracing, enabled, true or false. Maybe the name should have been flipped around, but it's allow and enabled. And so that says, I actually want to trace these things now and put them somewhere. So the putting somewhere, there's kind of two options. We'll take a look at them. One is, you can see it says local here. That means on this machine, on this host, and there's a proxy option. So if you want to configure them to send them off to a proxy and you want to trace them that way, you can do it, or you can write them to disk. There's a bunch of filters here as well. You can see filter, request, response. They are rules, which are filters. And that lets us say, I want to trace this stuff, or I don't want to trace this stuff. And of the things I trace, what data do I want to keep from all of those things, right? So for instance, if you are getting, if you're getting massive PDFs back, right? You're getting 20 megs worth or a gig's worth of PDFs or a zip file or something, do you really want to keep that trace data in your trace file? You may just want to know that you got it. You don't actually want all of that data on your files on disk. I mean, a gig of memory is also not the world's best thing, but at least it goes away when the thing finishes. All right, so trace files local. Again, by default, this is kind of a minimal set. It just traces everything. It writes to disk in a couple of ways, right? We have two options. One is a formatter, one is a writer. They do what they say, right? One says, I've got a trace set of data for this trace, for these requests. How do I want to format it? And so in the box there's two. Both are JSON, but there's a HAR formatter and a JSON formatter. JSON is just vanilla progress chosen format to write, but HAR is a quasi-standard. We'll talk about it in a bit, but it's very commonly used in web applications, I suppose, including browsers, including REST clients, a whole bunch of things. And so we can get some choices with our writer, right? File writers obviously writes to disk, and we want it to go in there. We've got some tokens in here which we can resolve to give us unique file names or whatever. So that's going to go to my tempter, it's going to go into a trace output folder, and it's going to have the date and timestamp in there. So we can customize that. HAR is, if you've ever looked in your browser and you right-click it, you can save as HAR. If you use something like Postman or Insomnia REST client, all the browsers use Firefox, Chrome, they all have the ability to write HAR files. There's a bunch of tools that can read it. So this link over here, I'll show you an example in a bit. So they can read that. They can say, okay, well, for this data, I can show you where stuff took longer, what the data looked like, all that sort of stuff, which is useful, a standardized format. You could potentially send these HAR files then off to another service. I assume part of the use case for building this feature was to put it into kind of the open telemetry stuff so that you could just send this data off to a Datadog or a, I forget the other company's name I was thinking of, but somebody like that, a large data gatherer, a large tracer, it's going to bother me till the end, and then they can potentially read this in their standardized tools, right? You don't have to invent the wheel and invent the format. All right, so now we'll look at how we can do that. How can we trace to file? So in this time, I can actually do something. All right, so I'm going to get rid of my request raw. So as you would have gathered, the first thing to do is turn the feature on. So what we're going to do is we will just say allow tracing true. We'll allow tracing true. So we're going to turn the tracing on here. The second thing that we need to do, and I have a bunch of them in here, we've got a hctracing.config. Hopefully you can read that okay in the back. And so that's got a formatter in there, the HAR formatter. It's got a writer, the file writer. And we're writing to a file here in my temp directory that's got the timestamp, that's got, sorry, the date, and then the trace of a timestamp in it, right? So we can put the data in there. The rules over here are a couple, and we have the filter rules right at the top, but we have request and response rules, and these are data rules. So what data do we want to keep? We have a body rule, a cookie rule, a header rule, query string rule, and so that says they know how to gather individual pieces of the HTTP request. So rather than just having the whole blob put in there, the whole thing, we can say we want to selectively choose parts of it. And we're saying just give everything, allow all is the policy. Similarly on the response side, body, cookie, header, header, header. Well, I've got two headers in there. I only need one header. Body, cookie, header. There's no other data on the way back, right? There's no query string on the way back, for instance. So we can gather all of that. So now if we run our request, so now we'll run our call again. So we've enabled, and the other thing is make sure we've enabled it. That would just be my luck not to. All right, so now if we run our request again, it's going to go and chug, and it's going to come back with a 401 as we expect. But now, in my, we can hopefully see there's a folder there with today's date, 220901, and with a trace file in it. Oh, it's only got one in there, that's weird. Oh, I know why. So that's just JSON. I'm just going to format that. And that's got a number of entries in it. What's the best way to show you? 1, 2, 3, 4. So it's got 4 different entries in it, right? And they look like that. When did they start? How long did it take to connect? How long did it take us to get the data? Here's the query string we sent. Here's the headers we sent. That's how big the headers are in bytes. All of this kind of standardized stuff. On the way back, we didn't get any cookies. We got a 302 back, blah, 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 blah. Then we went off to get, and we got a 302 back, right? Or 401 back. It's unauthorized. So we did the redirects. We've got all of this stuff. So this is pretty nifty and gathered, right? And we've got the whole thing. Content type on the way back. It's a base 64 encoded body, which I can show you what that looks like. You know, we can put it back in our base 64 decoder. The internet runs on base 64, not on Duncan. And so that's just the HTML page that you would get from Pazoe saying, hey, you got to log in, right? Somewhere over there it will say it. Unauthorized failed due to bad credentials. There we go. We can also analyze it here. How did I do this again? Back here, choose file. And we will go and select the file over here, not preferences. So we can look at this in this tool. This is just nice because it's got a pretty interface, open, and voila, right? This is something written by Google, and now we can see number of requests, how many bytes, how many uploaded bytes, downloaded bytes, the timings, all that good stuff, right? This has got more data is available in HAR than what the HTTP client does. So if you do a browser, so for instance, if we look here, if we look inspect here, then we can take our requests. I'll just do them again, resend. So we can pick a request, right click it here, and you can say save all as HAR. You may or may not be able to read that. There we go. So the same format, right? It just looks slightly different because the data is different. Or the data is different that we send. We don't have all the information. So for instance, the ABL client doesn't give us information on how long it took to resolve the DNS queries, right? The browser can do that on its own, and it measures that. Doesn't know how long it took us to do SSL connections. That the browser knows. But we do know how long it took us to connect, how long it took us 6 milliseconds to send that data, 250 to receive it, and what was the data. So that's really, really nifty. And that's just me going beep boop. All right, so that's simple tracing to file, and I think in most cases, and in many cases, that's going to be adequate. All right, for proxy is much simpler to set up. We say type proxy, we give it a URL, and because it's a proxy, right, the way, not obviously, the way proxies work obviously is, I just said not obviously, the way proxies work, not obviously, is that the whole request is sent to the proxy then sends it on to wherever it needs to go. So there's no, you can't send half the data to the proxy because then the server on the other end can't consume it. Similarly on the way back. So we can set that up, but we just send the data. So a quick look at proxying, and I need to start Fiddler. There we go, Fiddler Classic. And we'll come back here. No, not you. So that's running, the default port that runs on is, don't save. The default port that runs is on 8888. I did want to show you in the client log, or in the log, when we do the tracing, and I didn't show you that earlier, I should have, is at a high enough level, here's the rules we're under. Tracing output for local config goes to that file there, to a file name based like that. So it just tells you in the logging where it's going, what kind of you're doing at higher levels, right? These are debug levels. Some of the logging is a little lower level. If we turn the tracing off, what that looks like is I'll just run that again, 401 again, choink, and that basically tells you in the logging, here's the file it dumps to, right? So some of the information is there, the connect time is there. Where's the read handler time? 109, but there's a couple of bytes, so there's that. There's total time, total size. And again, you can see the request and the response files go to that same file name every time, which is not what we want. All right, so we can set it up to do a proxy. So I have another file in here, which is called cunningly proxy. There we go. And so I'm just going to copy and paste that into my config file here. And that's the minimum I need there. The minimum I need there. That's the minimum I need there. And so we're going to send the request off to 8888. In Fiddler over here, let's just clear all of that. Remove all. We'll run our request again. So turn tracing on. We've enabled it here, and we're going to send it to that URL or that host. Invalid cast from that to that. That was unexpected. All right. Where was our request? Hopefully I can see it here. Teams, Office, There we go, I'm sorry. So you may or may not be able to see that, but that is the request we sent. I'm not sure why it failed on the return, but that was one of the requests we sent to, where'd you go? Inspectors. That was the request we sent to that, that was the request we sent to the proxy. Yes, Peter?
Just got a question saying, I might have missed this, but from which version of Progress are these tracing config tricks available?
So the question was, when is this available? From which version is this available? And the answer is from 12.5.
Can we backport to 12.2?
Question is, can we backport it to 12.2? In theory, yes. I mean, practically, yes as well. It would depend on Progress Product Management wanting to do that.
Now we have the source code as well, so if you just compile it and run Progress.
I won't answer that on the microphone, but yes, you could do that. So the comment was made that since Progress provides the source code, could you backport this to yourself to 12.2 and run it there? And the answer is yes. I don't think it's got any features that depend on 12.2. Don't remember the var statements or the plus equals. Maybe, maybe not. I think we may have been thinking about potentially backporting it, but there's nothing special. There's no special, other than the syntax sugar like that, there's no special features that it depends on. All right. So other than the thing that didn't work, that's how we do the proxy. If we decide, let me just turn comment these guys out. If we decide in our code, and we can do this, we say via proxy, HTTP, localhost. Right, so we've now said, so the HTTP client has always had the ability to specify a request or a whole client go through a proxy. You've been able to do this since day one, I think. So what we have now is in the code says, hey, I want to go to this proxy. And this code here doesn't know anything about the configuration of the tracing. So if we do this now, and we say, okay, we're going to say compile and run this, it's going to do what it does. Right, it's going to come back with a connection failure for, because I killed Fiddler, didn't I? But it doesn't really matter from this perspective. But in the log file, we get a message saying, hey, you've configured the tracing to go to a proxy. The fact that it's going to the same thing doesn't really matter. It just says, you told me in code you want to go to a proxy. I'm not going to override that because the admin wants to override it, right? The developer wins this battle, this one battle. Maybe he wins some others, but this one, or she, but this one is a developer win. Right, so you can, so again, it's kind of just keep it the way it was. The intent of the code is to go to a proxy. You don't want to go to your proxy because it may be to, so you may have a proxy that is local that you want to use for tracing, but that goes to a different proxy because you want to go outside of your firewall through the proxy with Squid or something like that. All right, so rules. Mentioned them a little bit, and I said there's well, I'll go backwards. There's two kinds of rules, filter and data. So filter say, am I gathering data on this, request? And data rules say, which data do I want to keep? Right, so two different functions. They're both rules, but they're slightly different. They work more or less the same way. So there's two parts. You say either allow everything and provide exceptions, which means deny the exceptions, or you say deny all and you keep whatever's the exception. Right, so kind of standard kind of thinking of rules, right? So you may say, I never want to see anything except, well, if it comes back and it's a 401, I want to see that. Right, I'll go through what the rules are in a sec, or what the provided rules are in a sec. So you can control what you want to see, and you can control what you want to trace. So filter rules, again, by default, all requests are allowed through. If it's enabled and there's no filter rules, we just let it go through. There are four kinds. URL patterns, excuse me. So you can say, if the word authorize or login is in the URL, don't trace it because we expect there to be sensitive information in the body and we don't want that going out. Similarly, if there's a query parameter, if you've got the word bearer in your query parameter, right? Sometimes some APIs want the token sent in the URL rather than in the body or rather than in a header. We don't want to do that. If it's a particular content type, we don't want to trace it, right? For some reason. And that's for requests or responses. And a status code, right? You may or may not want to trace a particular status code. If you only want to see the 400s or the 500s, right? You don't care if it succeeds because everyone is happy. So you can filter by that. Similarly, on the data rules, they control, as I said, what gets stored in the output. The default here is store nothing. So it's kind of opposite to what the filter is. The filter is allow everything. The default for data is store nothing. It keeps it in this object here, this OpenInternet HTTP trace exchange data object, which is just an OOABL object with a ton of properties that contain all of that data we saw in the JSON file, maybe a little bit more, except for those two headers. Proxy authorization and authorization headers are obfuscated. You can see that there was that header in the request. You cannot see what the data was, right? There are ways of doing that in the ABL because it gets passed by parameters. And if you turn 4GL trace logging on, you can see it. But the point of this is you can't just pick up this file off disk and be like, oh, look, there's the bearer token. I want to use that again. Okie dokie. Filter and Demo roles. All right. Oops. Back we go. Okay, so we'll put the client log away. So what are we going to do here? Right, so we're going to look at, let's just go to our file one, because that's got, so again, just to go back and put this back into our live one. So you can see we have these various rules. Note that the whole class name is here. And we'll get to that when we talk about customization, but the whole class name is there, right? And a policy, allow all or not. Is it this one that's got the extensions? All right, so here's an example of an extension one. So you can see, for instance, we have a status code rule over here that says, let them all through, but if there's a 401 or a 403 response, don't trace that at all. We don't want to see those because reasons. This is slide demo, so think of a reason for yourself. We can also alter, for instance, if we want, let's do on the body, let's say we want to store the data on the body. Where's my body data rule? And we want to say here, I forget the syntax. I think it's just like that, application. Right, so we don't want to, you can do an array of them, right? So we want to store the body, but if it's JSON, we don't want to store the body, right? We just don't want to do that. And so we can go back to our, so that's, we've said, show everything except for 401 and 403. So I'll just take those away because I do want, I think the 403 has got a, the 401's got an HTML body. And so for our requests over here, pachink, I'll just take that away. Take the proxy away because we definitely don't want that to work. So if you have a proxy like this, for instance, and you set the tracing up to be local, all works just fine, right? Because we don't touch the, we're not trying to use a different proxy. So that just works as expected, or as you would expect. Compile, and we will run that again. And we get our 401 back, and then we get our new trace file over here. So if you take a look at this one, oops, Control F, Control S. So we said we want to see all data. Did we not do it in the right place? We did not do it in the right place. So we're going to see all data. And we're going to put that into our config file. So we want to see all data except for JSON. Let's say we want to trace all data except for, I don't remember the syntax of this. Did I have one? So for the query strings, we wanted to see all URLs except for open http.trace, trace, rule. And now I've got to remember the name of the rule. And we'll go to this guy over here, OpenEdge, not OpenEdge, OpenEdge.net, HTTP trace, where's trace rule? And that is the URL rule. So it doesn't have a name, URL rule. And our policy is going to be allow all, except for star, what do we want to do, star, it's this star, http bin.org star, right? .org star, and I'll get there. So basically what we're saying here is we're going to trace everything except requests to http bin.org, right? So in our case here, that is, so this request over here is going to do 2. That's going to go to http.org, one request, and then localhost 8810, the second request. So in theory, and hopefully in practice, if I've done it the right way, in the right place, it should go to the right, it should not trace that. Run as, and off we go. Gives us our result back, everything's happy. There we go, and it has not done any tracing. I would have expected it to do the one trace. But it has not done any of the tracing. I don't know why. There should have been two. There should have been two. I should have seen two in there. So I'm not entirely sure why I didn't do it, but we'll just. But that's the theory of the. Yeah, it's too local. So there's that one and that one should have been traced. These should also have been traced. I'm not sure why they haven't. Yes. Oh no.
In the body, I only had the exceptions from the content type. Scroll down. Is that supposed to be in the header rule?
Nope, it's not supposed to be in the header rule at all. Thank you. So that's so the header rule over there. You would say, well, let's do that. I mean, we can add a header rule in there. So that would be the body rule. So the body gets filtered by content type. The cookies get filtered by cookie name. Headers by header name. And so this header, if we, I don't know, let's do user. Use it. Right. And I'll just turn that off because that clearly didn't work for some reason. So we don't want to see the user agent header for some reason. We can do that. Again, that's our logged in one. So I'm just going to go, I want to see this request. Because that's got some credentials in and I want to show you that. So compile and run as that. Off it goes. We logged in, we're happy, and I think it's this one. Yep. And so a couple of things. One is we shouldn't see the, wait, what did I say? Did I put it in the wrong place? I put it in the wrong place because I put it in the response, right? So there's no user agent in the response, is there? Says he, I like HTTP. Not always so clever, eh, Judge? Anyhow, so let's do that again. Let's do that again, once more with feeling. And now we should see what I want to show you. So the header is not written in there, right? The other headers by default are written. We said allow all except for that, so that's good. It did the response came back and did a 401 because of the way we did the request, right? So we did the request, we said, send it there using credentials, which is a set of credentials. The server replied, which said, 401, you need to send me basic credentials. And then the HTTP client uses username and password here to make the second request and send the credentials. So there's the first response, the 401. It says, hey, basic realm is OE. It says basic, you've got to do that. Here's our second request, right? So all of these timings, and we send the data, the authorization data, like that. And as I said, we obfuscated it so you couldn't pick up this file and pull apart the username and credentials. Right? And that would be the same for like a bearer token could be in there. So you don't want to do that. We also said on the request, on the response, don't show me any JSON body that came back. I don't remember what this is. If there is a JSON body here, there is a body here. It came back as text HTML, so that's not going to get filtered. But on the response, the JSON would get filtered. Yeah. So we can do the filter rules in a variety of things. By default, the simplest one you're going to want to do is something like this, I think. Just allow everything, gather all the data. Obviously, there's certain cases rather do allow all and restrict rather than deny all and restrict, but obviously that's going to depend on the business requirements. All right, so filtered data. Any questions, comments so far? Good? Excellent. All right, but now I know you're all programmers and you don't want anything that anybody gives you and you want to build it all yourself, right, or extend it. So there's customization built in a couple of ways into this. So the first thing is, I don't know if you, I'm sure you noticed me going backwards and forwards, cut and paste from one JSON file into another JSON file. And that's because by default, the config file must be named hc_config.tracing, and it must be somewhere in ProPath. But what if you have your own location for this tracing file? Can you use that? So the answer is yes. You can say, use the file at this location, don't use the default. You could also build your own JSON from a database or somewhere, not use the config file on disk, build a JSON in a particular format, in that format that you've just seen, and pass that into the HTTP client. It kind of defeats the object of the exercise of having the administrator do the configuration of the tracing, but it was put in there so we could test, because the test infrastructure with files everywhere got really ugly and really messy. On the default file writer, you saw there were tokens in there. We can change the file name to point to anywhere, right? So if you don't like the file location, you can be hard-coded. You can have the same file overwritten every time if you want. I'm not sure why, because you could use the classic stuff. But you can specify where you want that to go. So that's kind of the shipped stuff, how do you customize that? And then if you want to implement your own rules, right? You want to write your own rules for filtering, for tracing, for data, you can do that. They have to implement that class, trace rule. It says you must implement the appropriate interface, but they do with a trace rule. Yes, Peter?
Another question is, why are the obfuscated herrings not red?
Thank you, Gus. Question was, or not Gus, Arthur, right? Arthur was our herring friend. Why are the obfuscated herrings not red? My skills in writing color into text files is not that good, but it was as good a string as any to do. Yes, so you can write your own classes in the implementation property for the custom rules. Implementation property, I don't know why I put that there. But for instance, if we added a Consultingwerk something rule, you would write it in there, add a policy and exceptions, right? The standard interface to override those. So you can add your own rules for your own rules. I think more importantly, and the implementation is really from the, let's get the fight with it here, was from the writers, right? So we have readers and writers, but need to match an interface as well. And this implementation over here as well as a whole class name, and so you could put whatever you wanted to there. So if you wanted to write these off to a database, then you could just write a rule to write them to a database, and you could put various properties. One of the nice things is that, come back here, because this is JSON, one of the cool things is we can say, well, we have a class name. If we find a writable property with that name that has the matching data type, we'll just automatically shove the data in that options JSON object into whatever the writer or the formatter is. So I think on the, I don't remember where it is, I think on the formatter, on the JSON formatter maybe, here we go. So JSON formatter. It's got a formatted property. So if we did, for instance, in our formatting over here, just by way of example, JSON formatter, copy and paste. Formatted true, because we want it to be formatted. By default it isn't because it's just smaller. And now we run the thing again. We will now see, now last one, pretty printed, right? So that's just by way of example of the customization ability. So you don't have to write builders to construct these things. You can pass data in from the config file into your own writer. So if you write a database writer, right, you may want to write the port name and the database name and all of that sort of stuff. You may want to configure that, so you can push that in. Yeah. So like I said, I think mostly people will want to customize the writers. Right? We have the HAR formatting and a vanilla JSON formatting. You may want to write it to XML if you want to. Whatever you choose to do. Pardon?
YAML.
YAML. It's like skinny JSON. You can write it to YAML, yes. Yes, indeed. We found the DevOps person in the room. Yeah, so I'll show a bit of that. I've shown you some of the configuration over there. Also, the ability to change the file name, which is really the one I like. So let's pick whatever this X is, the X one we want. yeah, so we can say use ext. This file name is exthctracing.config. Tracing config. Actually, we can do this even. New file. x.hctracing.config. That, right? That's the configuration. So what we're doing now here is saying for this HTTP client, right? So the client is really like almost a bucket that the requests go through. We're going to use the ext file, and the ext file, let's just say enabled is false, right? So the default file name we've said is false, or we can take formatting as false, just make sure all the falses, and we want to use this ext one, which is true formatted, and we don't have to put that in there, do we? So now when we run this, we will see we will have that yellow. When we run that, we will, did we turn ext? What did we turn off here? Body data rule, exceptions. No exceptions. Filter status code rule, allow all. In theory, we would have got a file in there. Oh no, wait, I know why, because there's no writer. We're using the default writer, and the default writer goes to trace output. Thank you for the hint. Goes to HTTP client something.trace. And now it's the JSON formatter, which looks like this, rather than what we look like. It's the same data. The fish are blue here, wherever they might be. Here we go, they're bluefish, redfish, bluefish, the trucks. And so we can configure it that way, right? We told it to use that file rather than the default. It's just another form of configuration. Yeah, I think that was that. So, and I think we're good on time even. We are good on time even. Well done. And this is an extension to the existing ability to log and trace HTTP requests. It gives you more data about or not more data necessarily, it gives you data primarily about more requests. So if you've got redirect, you've got multiple requests, you see them all rather than just seeing the one. Oh, I think I know, sorry, my brain just went back. So we only saw one file every time we ran that .p, and I'm wondering whether that's because it ran too quickly. Whether they, no, it can't be. Yeah. We should have seen 3 or 4, and we didn't. So we can trace data about more requests, and we can get better control over when that data is written without having to make code changes. Like, yes, you have to say allow tracing for the client, or allow tracing for the request, but that's it. And beyond that, you don't have to worry about configuring where that data goes, what it looks like, because that's the admin's job, right, or the DevOps engineer. Whoever's in control of the deployment decides, here's where I want the stuff to go, this is what I want to trace or not. Again, standard JSON-based formats, the HAR format is widely used, widely seen. We can pretty print it or whatever we want to do with it. And the other standard JSON is just a standard serialization of an object. As I said, you can customize that aspect of it for sure. Where does it go? What does it look like individually? So you can use the progress supplied format, but write it to a database. You can use your own format and write it to the progress supplied files, and file names. That all is A-OK. And then you can customize the rules if you want to. We've, at the time, thought we touched all the pieces that you might want to tailor. We got there. Maybe, maybe not. Like if there's something missing, then it should be easy enough to extend. It's available from 12.5, but pretty vanilla ABL code throughout. And so with that, I think I will turn it over to any other questions anybody has. Yes?
For SSL errors, does it really help in any way?
So the question is, for SSL errors, does it really help in any way? And the answer is no, largely because, so if you don't have the certificate or the root certificate or something like that, largely no, because those get thrown as errors from the HTTP client, and so they don't get caught. They don't get caught by the tracing. I'm 99% sure they don't get caught by the tracing. And so they just get thrown out, and the client, the caller, has to deal with them. The HAR format at any rate, which is what was used to kind of base the data collection, doesn't really have the concept of storing errors in it. It's just, this happened, and this is how long it took for these things to happen. Yeah.
Will be somewhere that, for example, HC trace conf default to provision it or how to create that from scratch?
Yes, so the question is the default config file available somewhere? Is there information on that? And the answer to both of those is yes, and the place where they both are is in the documentation. I thought I had, pardon? Help? They're in the documentation. There's a snippet of what each of the pieces are. There's a default one at the bottom. So the one actually I used here, I copied from the help, from the documentation site. So again, it's 12.5. Look for HTTP client tracing. I believe there is also a video in the, in the what's new in 12.5. I think there's a video snippet there, and that default config with the local, right? Not with the proxy, but with the local is in the documentation. Yep.
How it will behave if that default name HC trace conf is improper, that it will trace. If not, but tracing is set to true, that it will rise the error.
So the question is, if allow tracing is set to true and the config file does not exist in ProPath, what happens? Yep. Nothing. It just keeps on going. It doesn't trace. One of the goals was to make it as fast and as unobtrusive as possible. So you don't want to impact the performance of the actual request by measuring how long it takes. And so if it's not there, it just moves along. It figures that the request is more important than the tracing. So if, Let's see. I don't remember if it logs it somewhere, but we can double check that quickly. We just give this a name that doesn't exist. .bob, right? So that file doesn't exist. Run as joink. It works just fine. And our logging is, there's our logging. Does it have it? Does it have it in there somewhere? Not here, obviously. Does not. Oh, so it says has none tracing. It just says that it's disabled. It doesn't say why. But it just tells you that tracing is not enabled. It should probably tell you it couldn't find the file. It's Chris.
Good question. Can you have everything set, or does everything need to be set by the time you actually initiate the request? So you have time to set allow tracing, and you have time to specify the file, and all of these things get taken into consideration only once the request is made.
So to paraphrase the question, when is that config read and when is it applied? So the config is, I'll answer the second one, the config is applied on each request. So remember I said how the HTTP client does redirects? So it evaluates those rules, that whole config against each of those requests. So the initial one, then the redirect, then the other redirect, then the yada yada. Each one of those is evaluated at that time. So it's not just evaluated once and done. When is the config reread? There is code in the default reader that works on a touched basis. So if you load it in, so let's say you make a request, and I can't remember the default interval, 60 seconds maybe, but it basically says, if the file was changed from when I last read it, that config file, I'm going to go and load it again. So maybe not within the span of a redirect, that seems very unlikely, but you make a request and then 5 minutes later the application makes another request and you've changed the tracing between those things, it will go and refetch then, and you can configure how long it needs to look. It's 60 seconds because you don't want to be hitting the disk all the time to go and figure out whether the file has changed or not. Yeah. Any other questions? I will be outside and around if you have other questions about this. And thank you very much for coming, for attending.